Hey guys, and welcome back. In this video we'll be going over the pseudo ops or the directives of the DASM assembler, so stick around for that. Okay, so let's start with this directive, the pseudo op video, and let's go over some of the stuff that we've already seen, which is the comment. So as soon as you type the semicolon, whatever is after this, the compiler is gonna ignore it. So that's the first gist. And we have the labels. So we have a label here like start a frame, jump, start a frame. So this is gonna save the PC counter over here. It's gonna jump right over here. But a quick note, if I were to compile this, you see it's gonna work fine, perfect. But if I were to leave one space over here, or to compile, as you see, nothing, it didn't work. Like Demonics doesn't know what this is, because a label on DASM should be the first thing that you type out in the beginning of the line. So if you see over here, if I were to compile one more time, now it's happy. So just keep that in mind when you're using DASM. So now let's go over the directive you have over here in this file. And let's start the first one, processor. So I also have my DASM document open, and if you need to know one more time, it's under DASM, documents, and DASM. That's where our document is gonna lie on. So if you see over here in the documentation, it says somewhere if only runs once. It should be the first thing you do. All the rest is maybe declare. Only one processor maybe declare. Oh, it's right here, and the first thing you should do. So it's the first thing you should do. And it says over here that processor should up. One more first thing you should do, and the only difference is the integer formats. See below, and is referring for right over here. If you notice, it has the LSB and MSB, the 6502, and the rest of this has MSB to LSB. And these refer to the LSB as the least significant bit, and MSB is the most significant bit. And that is the case of a little Indian versus big Indian. So I don't want to mistype Indian, so let me Google this. Just little Indian versus big Indian. Here it is. Indian. That's how you spell it. And let me just show you really fast. Here it is. Let me bring this up. Oh, right over here. So we have the most significant to least significant, and here it has least significant to most significant. Let me just come over here and draw this out so you guys know what I'm talking about. Oh, I apparently opened Visual Studio. That's okay. So let me draw two boxes. Oh, each one of them is going to represent a byte each. One's going to be a big Indian, and the other one's going to be a small Indian. And in case you guys have noticed, but in case you guys wondering, since we use the 6502, we always been using the little Indian. So let me count it to make sure. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. My draw tool, different color. Let me take my draw thing out. Let me close Visual Studio. Let's do it like this. Okay. Whoops. Bring back you. Okay, draw. Okay. So if you remember from the 6502 videos, let's say I add all of this is all 0. Let's say I add 1. So 1 goes over here. Let's say I add another 1. So another one goes over here. All of this is pretty much going to be 0 and so forth. So let's say another one that's 11. Another one's 100. And if you notice this pattern, it's growing from this side over here. And this is the little Indian. So a big Indian is pretty much the reverse. So we're gonna start from here. So here is our one. Add one. Let's add one more. Let's add 10. Let's add one more. And let's add one more. As you see over here, it's growing in a different direction. Okay, I don't need my toe anymore, actually. Let's clear this out. So that's the least significant, the big Indian versus little Indian. So let me go bring this out over here. And as you notice over here, because the little Indian and big Indian, let's say over here, little Indian growing to this side, big Indian growing to this side. Let me show you over here. Why does it matter? I had it right over here. Oh, here it is. As you see, all of this has the same numbers of bytes in the same order. So 0, 0, 0, 0, 1, 1, 0, 0. But one is a big Indian, which represents the number 100. And this one's a little Indian. It represents the number 38. So it has different values. So make sure that we set the processor to the right one. So it's right over here. So that's the processor. The next one is the include. Let's go over all the files we have over here. And include is pretty much going to include a file, to our code. Include another assembly file. Here is our .h and your .h, VCS, and our macros over here. So it's pretty much going to get all of this. It's like a copy and paste, but we're going to include them right over here, both of these files. The next one is your segment. And here you have our segment. This is set our current segment, creating if necessary. And you can put .u, which is initialize, meaning when there is no values on it, it can be initiated. And just initialize. So to create an initialize one, you just put .u, initialize. And think of them as segment as different sections of your code. And each section needs a origin, org. Let's go to origin, org. So that's the current orange. You can set a value over here. So we have our exp, that's our operand or parameter. And here you have the default field value. It says a default value. It's probably 0. Let me check what the ESP refers to so I keep forgetting. It's somewhere over here. But that's pretty much like our parameter or operand or argument or so forth. So here we start at the F000, which is the Atari 2600. That's where the cartridge ROM goes to. So that's the origin. And next one we have repeat. It's going to repeat this code 3 times. So if I were to compile this, go over here. So it's right after STVSync. So here you have STWSync, WSync, WSync. So I didn't have to type ST star A and WSync. And as you see over here, I did the same thing but 37 times. So there's a bunch of 37 times over here. And over here 192 times. So as you see, it's a lot to type, so it's saving us a lot of time. So that's what one of the benefits of using this assembler. And here you have another origin. So this is this file, and here you have a word. If you remember, a word is 2 bytes, 16. and a dot over here represents the current PC counter. So all of this should be in this document over here. So let me go to byte. I know somewhere. Well, let's see if I pass. Oh, I pass it somewhere. Oh, it's all over here. And a word is a 16 bytes. So you're putting 16 bytes at the bits. I'm sorry, 16 bits. I mean 2 bytes. Make sure you get the terminology right. So FFFA. If I come over here, let's go all the way to the bottom. Here's dot byte, dot byte, dot byte. Here it is 0FF. So reset value is 0FF. So word at the current point 0FF, 0FF, 0FF. If you remember from the what was it, 6502 ASM? Yes, it is. Let's go alive. You have here DCB, which also have our DASM assembler, which is declared byte. It's the exact same thing. Here, remember I put this on the our emulator. I put this at a certain part of our code right at the end of it, and this is doing the exact same thing right at the 60 FFF5 FFFA. Put 2 bytes, 2 bytes, and 2 bytes. So the last one should be FF. 2 bytes, 2 bytes, 2 bytes. So that's the dot word. Have a 2 byte over here. And we have N, which says N the assembler. Let's go over the word over here, see if I have it over here. Should have it over here. Oh well. So I'm looking at the timer over here, and the time's getting a little bit too big. So I decided to split this video into another part. So in this next part, we're gonna go over the rest all of this directive pseudo ops you have over here. Just a quick note: I'm not sure how to work this DV. Pseudo Op. I tried to find some examples online. I didn't have any luck with that, so I'm gonna skip all of this. I mean, I'll go through what the manual says at least, but that's gonna be it for this video, and I'll see you in the next one. Thanks for watching.